Today's lesson is called factoring. So today is September the 24th, 2014. Okay, some of these ones we'll have seen before. I'm just going to review all the different types of factoring. Some of them we did in our grade 10 review, but not all of them. Okay. I'm going to start with difference of squares. Yes, this is a no. This is a no. Okay, for A, we're going to start with x squared minus 49. Okay, so this is difference of squares. I'm going to do it a different way, probably than your grade 10 teacher did. If you want to do it the same way that your grade 10 teacher did, that is fine. I will not be offended, as long as you still get the same answer. The way I will do difference of squares is this. I'm going to start with Colton. Colton, what is the square root of x squared, please? X. So I'm just going to write this as an optional step in the middle. Kylie, what is the square root of 49, please? 7. This is an optional step in the middle. You don't need to write that. Okay. And remember how difference of squares goes? Nope. Okay, you guys are honest. That's good.
Let's say the bracket is something, and the other one is something.
Now, where do the somethings come from? One is a plus, one is a minus. Where the somethings actually come from is this is the first something and that's the second something. Okay. Now, you can go right from the first step to the last step if you need to. I have no issue with that. Okay, right? But that middle step is just running with squares. All right. To be a difference of squares, 3 things have to happen. What's something unique with an x squared minus 41? Somebody tell me about that, that when I visually look at it, tell us the difference of squares. Go ahead.
Subtraction?
Yeah, the last term is negative. What's the second thing that tells me it's a difference of squares? Terms, okay? I'm going to say no middle term, no x term. If I say no middle term, will that make sense? No middle term. Because generally, right, like an x squared term would have like an x squared and x and some no middle term. What's the third one? This is going to be brought up for debate when you get to calculus, but for right now, we're going to say something else.
X squared?
Well, sort of more than that. Okay. I'm going to say number 3, they both square rootable. Okay. We're going to get numbers that are both square rootable. Now, before I say that, I can guess all my hecklers on the internet are going to give me a problem with that. Okay, so I'm going to. I mean, technically, you can factor this with the difference of squares. You don't have to in grade calculus. How would you do that one by difference of squares? What would that be? How would you factor that using difference of squares? You can actually. You want to say you can't, but you actually can't. This is technically what it is, but that's yeah, I'm not going to do that in this year. But in the future, you'll be able to do stuff like that. So it's possible for the second number not to be square rootable, but generally you want it. So you see what I did there, right? Root 2 and root 2. Okay, right, but generally it's not going to be that way. Let's go on to example 2 here. This is coming back to most people from last year, I hope. You at least saw it somewhat. All right, this is my favorite question, is one like this. Example 2. Okay, in this unit we'll be solving everything using factors. So although Mr. Lacey likes the quadratic formula, okay, for these questions we're solving everything by factoring. Looking at that one, that sort of looks like a difference of squares. Okay, and it is going to be because that's the heading that we're under. But what's the problem that I see first of all? Equal 0 is okay, we'll deal with that in a sec. Okay, let's pretend equal 0 is there. Zoe, go ahead. Yeah, there's an x cubed and an x term. Okay. As well, can you take the square root of 50? Can you take the square root of 98? No. So what can I do to make this one work better? Go ahead. Okay, I hope
You can divide it by 2x.
yes. Okay, so what we're going to do is, this is, I think, when you said thingy, I think what you meant was Common factor of 2x, I think is what you meant. Okay, so what's going to happen is you're going to be left with take a 2x out of both of them. They can both be divided by 2, they both have an x. And please put your phone away, thank you. Okay. When you divide them both by 2x, what are you left with, please? Okay, brave soul to volunteer. Yeah? Now you said 25x, but it's x squared, right? Because there's 3 there, you get rid of 1, there's 2. Okay, this is where I'd like everyone to take the next 30 seconds of their lives and to solve this with difference of squares. Factor that with difference of squares. Now, Madison, why is this difference of squares? It's not vertex form. Good try, though. Okay, but if you take a look now, there's 2 terms here, right? This one's a negative like it's supposed to be, so the last term's negative, there's no middle term, and as well, both of these are square root of 1. Okay, so it's something nice that it can work out to be. Okay, I'm going to give you about 30 seconds. I'm going to pick on Jesse to show off his factoring skills. Jesse, go ahead. Yeah? Yeah. Yeah. Again, if you want to show this step back here, go ahead, like the in-between step. Yeah, but that's fine. Now, excellent. Okay, oh, sorry. Yeah, go ahead.
Does it matter if the plus or minus?
No. Think of it, the question was, does it matter if the -7, if plus 7 is before the -7, that's okay. Think of it when you multiply, like 2 times 3 is the same as 3 times 2. But they both give you the same answer, whether it's flipped, so that's a-okay. All right, now here comes the tricky part. So if you're fading out of today's class, now's the time to fade in, okay? I want to solve that equal to 0. What does that mean? There are 3 roots here, it looks like. I'm going to solve this equal to 0. What am I going to do? Oh, goodness. Okay, let's slow down. I'm too excited here. Let's pretend that 2x wasn't there, and that was equal to 0. What did we do? What would we do? Thank you. Make them both equal to 0. Okay, is what you're going to do. So in this case, we're going to say either 2x is equal to 0, or 5x minus 7 is equal to 0, or 5x plus 7 is equal to 0. Okay. Now, again, if you were to FOIL to get something back like what you started with, right? The whole reason you factor is to solve for this. If I have 2x is equal to 0, what does x equal, please? What does x equal, sorry? Okay, I'm going to slow down. Okay, if you have 2x equals 0, how do you isolate x? What do you have to do?
Divide by 2.
Thank you. What is 0 divided by 2? 0. It's not a guess. 0. And 2 is... And that just sort of makes sense. If you plug in a 0 for x here and a 0 for x there, it's going to equal 0, right? All right, 5x minus 7 equals 0. Can I get a brave soul to tell me how to solve for x? David, go.
Move the 7 over, so it's 5x equals 7.
Yeah.
And then divide by 5.
We did this before already, right? We've done this, right? I think so. The roots. Beginning the x. All right, Vanessa, can you find the last root for us, please?
So it'd be like 5x equals -7.
Yeah. Now, although I know Mr. Lacey loves quadratic formula, it is a lot faster going from here down than it is quadratic formula this. Again, I apologize, Mr. Lacey's around, he's hearing me. You're a wonderful person, Mr. Lacey. But I like factoring, but I don't really like that. Then I don't get a lot of hate on this.